So in this section, we are going to talk about assignment problem. Basically, if we have several jobs, and then I ask several contractors to do the jobs, and I ask them to first provide that how much they will charge for each of the jobs. Okay, then the other thing is if I make sure I have um, the same number of jobs and the same number of contracts. Of course, we can make them differently, but that's just like what we did for transportation problem. We can sign up some dummy and person or dummy jobs, right? So in this way, we just assume there are n jobs and n persons, and then we want to sign them to do this job. But the whole purpose is we want to minimize the cost, right? So as we already asked them to give the price for each job, right? And in this way, we can set up an LP problem for it. So that the CIJ, you could see in the LP problem, CIJ, that's ith person, give the price for the J's job. Okay, and now we just want to minimize them. And here, please understand, each person may take one job only, and a job only need one person to finish it. Okay, so in this way, that the variable xij actually represent the ith person to take the j's job. So whenever the ith person takes j's job, then xij equals 0. If the ith person the uh, the IXIJ, if the person the ith person didn't get the J's job, then that is 0, right? So for this LP problem, and the solutions Xij for for each basic variable or non-basic variable, the difference is 1, either 0 or 1. Okay, so we have one person takes job J, then Xij is 1. If the person the person I didn't take the job 1, then I1 Xi1 equals 0. Just like this, right? Now let's look how may we solve this kind of problem. So we also start with an example. Suppose there are 5 jobs for 5 persons, and the cost matrix is listed in the table. Okay, so here you just need to make it a notch on the left bottom. Okay, so you could see that the first person of the first job cost 2 units, or you say $2 or $200 or $2,000. That depends on the units, right? Okay, so that the first person of job 1 2, job 2 4, job 3 5, and job 4 1, and job 5 4. And then we listed that. Then we could column, you look at, okay, job 3, that the first person asked 5, and the second person asked 6, third person asked 8, and fourth person asked 5, and the fifth person asked 2. So in this way, probably from this table, if you don't know LP problem, you can simply, okay, choose those. For example, if you choose just from the table, you could say, oh, first person, because ask one for the job 4, you choose that one. And then for the second person, you probably choose 4. Second person choose job 1. First person choose job 4. Second person choose job 1. That's cheapest. We just look at the cheapest. But the third person offers the cheapest price is for also for job one. That's three. And you probably say I turns to job five. That's fine. But the third person, the fourth person, you just work on. If you can, if you don't know LP problem, you probably can from this table to find the cheapest price. And if we know that LP problem here, we can use some method to work out it. And here how to minimize it, and we first introduce a permutation matrix. A permutation matrix is what you look like that a matrix who all the entries either 0 or 1, and all of them, most of them are zeros. Each row or each column can have only one there. Okay, you could see that first row we have 1 in the third column. So in this way, you can cross that in the third column, the rest should be 0. Okay, and the second row and the second the entry is 1. The rest should be 0. And you could see that above the 1 or below 1, all zeros. Okay, and in assignment question problem, we normally use a permutation matrix to give a feasible solution to the assignment problem. For this one, you could from the permutation matrix, you could see that okay, the first person take job 3, second person take job 2, and third person take job 1, and the fourth person take job 5, and the fifth person take job 4. So you just well we where we have 1, then that's the just the cross. You could see the feasible solution there. So we always have feasible solution there, right? You can just regularly write up just whatever you want to write. Just keep this in mind that in each row, each column, you may have only 1 there. The rest should be 0. Okay, so now in this for this one in example 7.5, I wrote that the table, the cost table as a matrix, as 5 by 5 matrix on the left. And what we do work on this cost matrix as follow the theorem on the text 5.3. Now before we do that, we just read the theorem 7.1. If the cost matrix for an assignment problem has non-negative entries and at least n zeros, then an optimal solution to the problem exists if n of the zeros lie in the positions of one of some m by m permutation matrix P. The matrix P represents an optimal solution. Okay, we just leave it aside. And first of all, we follow the theorem on the textbook and to work on the matrix we wrote on left. So the first step, one, we write down the cost matrix, and then for each row of the cost matrix, subtract smallest number in the row from each number in the row. Okay, subtract the smallest number in the row for each number of the row. If you look at the left side, the first row is 2, 4, 5, 1, 4. So that 1 is the smallest number in the first row. So we each entry subtract 1. In this way, you could see that I did it on the right of the matrix, right side of the matrix. Then 2 become 1, 4 become 3, 5 become 4, and then 1 becomes 0, 4 becomes 3. And the second row, that the smallest entry is 4. So we all the entries on the second row, we subtract 4. So that becomes 4 minus 4, 0, 7 minus 4, 3, 6, 2, 11 is 7, and 7 is 3. Okay, and we work on the rest. That's 0 and 3 on the third row. 3 is the smallest one. So minus 3, 0, 6, 5, 7, 2. And the fourth, no, that's 1, right? So 0, 2, 4, 0, 3. And then the last row, that is 60101. Okay, so that we worked out for all the rows, and you could see on the left of this matrix I already did the further cross because we don't want to repeat write the matrix. So here the next steps, once we finish each row, subtract the smallest number in the row for each number in the row. And then for each column of the resulting matrix, we find the smallest number 2 and then subtract it from each number in the column. So once we work out it, you could see that the first row or first column, when we subtract it, that becomes the 10006. And 1006, the smallest number is 0, so we don't need to do anything. And for the second column, it has 33620. In this way, we still keep them. We can the smallest number is 0, we keep it. And the third column, we have 4 to 5, 4 to 5, and the 4 1. So 1 is the smallest number, then we subtract it again. You could see I have a cross on 4, then I got 5 and 3, and cross on 2, that's 1, cross on 5, that's 4, and cross on 4, that's 3, and cross 1, that's 0 there, right? And then the third row, because we have that 0, 7, 0, 0, so no change. The last row, we have 3, 3, 2, 3, 1. So subtract 1 becomes 2, 2, 1, 2, 0. Now I just rewrite the matrix. Then that becomes 1, 0, 1, 3, 3, 0, 0, 3, 1, 7. You could see that one, right? So we rewrite it. And then we go to step 2. We find minimum number of lines through the rows and columns of the reduced cost matrix so that all zeros have a line through them. If the number of lines is n, an optimal solution is available, we can stop it. Otherwise, go to step 3. Okay, so now you could see we have zeros on first row. We have a lot of zeros on first column. We have a lot of zeros on fifth row, right? And here we also have the column a 0 here. Just on the third column, we have a lot of zeros. So in this way, you could see on the right side under this matrix, and we only need 3 lines to cover all these zeros. So first column we cross a line, and fourth column we cross a line, and the last column we cross a line. So all the zeros are covered by these 3 lines. So in this way, we have this matrix is 5 by 5. So here we only have 3. The least number of lines cover all the zeros. In this way, we don't have optimal solution. Okay, so we go to step 3. In step 3, that we define a new reduced cost matrix as follows. We find the smallest number of the matrix which does not have a line through it. Subtract this smallest number from all the uncovered numbers and add it to all the numbers which are twice covered. Then go to step 2 again. So what we mean is here you could see when I crossed these lines, you could see here we have some entries who are not be covered by lines, right? So you could see there's 3, 3, 2, 3, 1, 2, 6, 4, 1, 2, 3, 2. So here, what we do in the step 3 is among those uncovered by lines, okay? And what we do is choose the smallest number. That is 1, right? So each of these uncovered entries, we subtract 1. Okay, when we subtract 1, 3, 3, 2 becomes 2, 2, 1, and 3, 1, 2 becomes 2, 0, 1, and 6, 4, 1 becomes 5, 3, 0, and 2, 2, 3 becomes 1, 2, 1, right? Once we done this, but don't forget for those entries covered by 2 lines, say that the bottom 6 and the entry what in 5 4, right? That 0 is double covered, so we turn it add the 1, which this is the number each entries uncovered entries subtract to, right? So we just simply add 1 to this double those entries with double line crossed. So 6 becomes 7 and 0 becomes 1. Now we have a new matrix then. In the new matrix, we back to the step 2. When we back to the step 2, you could see that we want to use least number of lines to cross it. And here you could see that I crossed it that the first column and the last row. Then you could see we have zeros, other zeros on first line, first row, second row, third row, fourth row, and this one we have to use that 5 lines to cover it. Here, just see that I cover this one, I cover this one here, and then for these 4 zeros, how many we covered? And I could use 1 line cover this, right? And then these two I have to use 2 lines to cover it. You can see that I have to use 2 lines to cover it, right? So here I cover it. You can use this cover, doesn't matter you use that horizontal covering or line to cover it or vertical line to cover it. Anyway, when we try to cover it with least number of lines, then here you can see we used 5 lines, and the size of this matrix is 5 by 5. So in this way we have an optimal solution. And how to choose the optimal solution is that we make a star at those zeros, but keep this in your mind. Each column and each row we may have only 1 star on it. So first row we have only 1 0 there, right? So we put a star on the 0. We put a star on the 0. For second row we have 2 zeros there, right? Which one should we choose? You may choose the first one, that is the entry 0 entry on second row first column. You may choose that one. Okay, you may choose it, and then you could see here if I choose this one, so the other color, different color, I could choose that purple one. So I choose this one with a star. I can choose this one with a star. Okay. When you choose this star, the rest star is gone. So in this way, the third row, this one we already choose, so we have to choose this one, right? This star. And when we choose this star, and you could see we can't choose this star, we can't choose this star, and we have to choose. We may, okay, for this row, there's no available zeros there. So that means we can't do it. We cannot go any further. And because each row, each column, we may choose one star there, right? And in this way, we just, okay, we give up that we can't go any further. So in this way, what we do is we do not choose the first star in the second row. We choose the third, third entry and on the first row. So you could see that once I choose the entry there, then I can go further. The third row, I choose the star on the last entry, and then the zero entry, and the fourth row, on the fourth row, I choose the first one to be the star because that the other zero is already chosen in that corner. Fourth corner is already chosen, right? And then you could see that the last row, second zero, and the zero after 7 it was chosen to be a star. And in this way, we got our optimal solution. And what's the optimal solution? We write those stars as permutation matrix. So for those 0 with star, we put them as 1. The rest of them to be zeros. So this will, okay, now look at this one. So here you could see that for those 0 with star, I put a 1 in the permutation matrix, and then we got the optimal solution then. That is the first person take job 4, and the second person take job 3, and the third person take job 5, and the fourth person take job 1. Oh, sorry, takes job 1, and the fifth person takes job 2. And if we back to the table, and you could see that the first person takes job 4, that's 1, right? Cost 1. The second person take job 3, that cost is 6. That probably is a little bit expensive, a little bit more expensive than 4 job for the person take job, but you could see that other workers give the price for job 1 cheaper, right? So we give that job 3 to the worker, second person, and then the third person we give that job 5, and then the fourth person takes job 1, the fifth person takes job 1, 2. So in this way, that is what 1 plus 6 plus 5 and plus 1 plus 1, that totally equals 14. So the optimal solution is writing in this way. Cost, you back to the table to write them for the workers. Give that how much it costs for each of job, right? Which one you choose, and then write the permutation matrix. That is the optimal solution. Okay, so this is about the assignment question. And please pay attention here. when we talk about the assignment question, is we want to minimize the cost, right? We want to minimize the cost, but sometimes we want to maximize the performance. Just if you are a manager, you want to have some different jobs you want to assign to your staffs, and then you know how good they at each of the jobs. So you could probably want to use an LP problem, that assignment problem, to give that the job to the person more suitable um, for the performance, right? So here, how may we work on it is that in this case, we want to maximize the total value of the performance. And how may we deal with this kind of problem? It is not a minimization. So in this way, you understand, we want to do maximization. And as we work on LP problem, this means we have to multiply negative to it, right? So here, let's see example 7.2. In this one, we have a manager has 3 jobs for 3 person to fill it. And we denote the jobs as job 1, job 2, job 3, and these 3 persons as A, B, C. Okay, now he knows that each person he gives a rate for each of the job. So that person A, job 1, 6, job 2, 8, job 3, 12, very good at job 3. And person B, job 1, job 2, mine 3, performance is 3, 4, and job 3, 10. And the person 5 and the C, job 1 is 5, job 3 is job 2 is 3, job 3 is 8. So you could see that all of them are very good at job 3. But for job 1, job 2, they are someone okay, someone is not. So in this way, how may we assign you probably say, oh, of course I signed the person A to the job 3 because the performance is really good. But for the rest of the other two work on job 1 and job 2, you can see not so good, right? Now, if we set up an LP problem for this one, that is maximize the P, right? And maximize P, of course, we can convert it into minimization problem that make it minimize negative PIJ, right? So when we have the negative PIJ, how may we use the assignment method to solve it? Because if you back to read the theorem 7.3, if the cost matrix for assignment problem has non-negative entries, but when we work out this one, it is when you make up the performance matrix, all the entries are negative, right? All the entries are negative. Then how may we work out it, right? Here we just have a little change there. What we do is the small entries in the performance matrix, we just find that one, and then we add the positive to it. For this case, you see that the smallest entry in the performance matrix, okay, that is minus 12. So we simply add 12 to each entry in the matrix, and that gives us 6, 4, 9, 8, 2, and 7, 9, 4. And then we use the regular method of assignment problem to solve it. So in this way, you could see that we just simply For the first row, we have nothing to do because the smallest number is 0. Second row, smallest number is 2. So 9 minus 2, 7, 8 minus 2, 6, and 2 minus 0. For the last row, that smallest number is 4. That is 0 and 4 minus 4, 0, and 9 minus 4, 5, 1, right? 7, 4, 3. And then the column becomes a 3, 4, the first row 3, 0, 0, second row 4, 2, 0, and the third row is 3, 5, 0. So you could look at the first column is 3, 7, 3. So in this way, we can work on it. Wait 1 second, and we can subtract. We just work out this one because we have a 0 there, or minus 7. Wait a second. Okay, now you just look at it that the column, first column is 6, 4, right? 6, 4, 3. And then second column is 4, 4, 6, 5. And then the last column is 0, 0, 0. So then we do the column subtraction, so that the first column smallest number is 3. So that 6 minus 3, 3, and 7 minus 3, 4, and 3 minus 3, 0. And then we got just work on the second column again. And then we got the matrix 3, 0, 4, 2, 0, and 0, 1, 0. In this way, we have to use 3 lines to cover it. And in this way, you could see that we have 3 lines cover those zeros, so we are reaching optimal solutions. Then we just simply mark the star on the zeros so that each row or each column has 1 star only. In this way, we can write it. You could choose that for the first row, you have 2 choices, either entry to what 1, 2, 0, right? And or 1, 3, 0. You can try those. If you choose that 0 on the entry 1, 3, then you could see the rest the zeros available. Then the second row without a 0 there, so you can't do it. You have to assign the star to the first second entry, that entry 1, 2, right? So once you assign 1, 2, 0, that entry in and 0, and then on the second row you can just simply give a star to the 0 at the entry 2, 3, and then the entry 1, 3, 1, give a star. So in this way you have a permutation matrix that is 0, 1, 0, 0, 0, 1, 1, 0, 0. That tells you to sign up that first the A to be job 2, and B with job 3, and C with job 1, right? So in this way, the total performance is 23. Okay, now if what if you don't do it? You just say, oh, I don't know this. I just sometimes people just, oh, this is assignment question, so I just use the assignment the method to solve the assignment problem. So someone just simply write down it. If you write the matrix down, you work on it, and what you got is the first person for first one, second person for second one, third person for last one, and in this way you got what 18. The performance is a poor performance. Okay, you minimize the performance. Okay, that's all about the course. Thank you for taking MATB 61, and please be safe and well.